Objective 4.1 is to create a sample space and a probability distribution table using description of events and probability rules. We're going to start today by focusing on just sample space. So a sample space is a visualization of the possible outcomes of an event. In probability, it's sometimes helpful to make a picture of all possible outcomes. This is for situations where there's more than one event. If it's just flip a coin once, everyone kind of knows heads or tails. But if it's flip a coin 4 times, sometimes it's nice to see what that would look like. In this first example, we are drawing 2 cards from a deck. There are 4 suits: hearts, diamonds, clubs, and spades. And I would like to create a sample space for the possible outcomes. So you notice that the 2 cards from the deck, that's the 2 different events that are occurring here. And all we're going to do is create a picture of what that might look like. So we could either get hearts and then another hearts, or we could get hearts and diamonds, or hearts and clubs, or hearts and spades. And you notice I'm just writing it out in that way so that I know that those are options and the reader knows those are options. Naturally, you can probably guess what's going to happen next. We could either get diamonds and hearts, or diamonds and diamonds, or diamonds and clubs, or diamonds and spades. Or we could get clubs and hearts, or clubs and diamonds, or clubs and clubs, or clubs and spades. Or finally, we could get spades and hearts, spades and diamonds, spades and clubs, or spades and spades. You notice there's a total of 16 possible outcomes here. I didn't have to do it the way that I did it, but if you follow a pattern, that usually makes it pretty easy to make sure that you get all of them. The next example is we've got 2 players, A and B, who are playing rock, paper, scissors, best 2 out of 3, which means whoever wins 2 games first wins the entire set. And we're creating a sample space again. So this could go more than 2 events. In our last example, there were just 2 each time. But this one could be more than that. So one possible thing that could happen is player A could win first, and then player A could win again. And then that would be done. Player A won twice, so player A won. Another possibility is player A wins, and then player B wins, and then they have to play again because no one's won 2 games yet, and player A wins again. Now player A has won twice, player A has won. Or player A could win, and then player B could win twice. This way, player B wins because B won 2 out of 3. You notice that's all the possible ways that could result with player A winning first. So the second half of this is going to be pretty similar. Player B could win first and second, and then they would win everything. Or they could win first, and then player A could win, and then B could win again. Or B could win first, and then A again. Every single possible outcome of this situation is written right here, so that's the sample space. Next thing we're going to do is use a sample space to create a probability distribution table. These are really interesting. So we're going to start with the sample space of example 3. Sorry about that. The sample space is what happens if you flip a coin 3 times. So coins, of course, could come out to heads or tails. So I'm going to do this kind of fast. You could get heads, 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 tails, heads, tail, heads, heads, tails, tails. And I believe that's all the possible ways that start with heads. And then we'll do the same thing for tails. So you could have tails, 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 heads, tails, 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 heads, or tails, heads, heads. So there's a total of 8 different ways that that this could result. The probability distribution table is a table that says the probability of events occurring based on our sample space. So notice that it says create a probability distribution table for the amount of heads you could get. That's not the only thing that it could have asked for here. It could have asked for the amount of tails, or how many times you get 3 of the same thing in a row, or anything like that. You always have to make sure that you look at what the probability table is asking for. So in this case, the amount of heads could be 0, or like here, tails, 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 that's 0 heads. Or it could be 1, like in this case. or it could be 2, like in this case, or it could be 3, like in this case. Obviously, there's no way to get more than 3 or less than 0 based on this situation. So what we're going to do is we're going to create a table that's going to be horizontally oriented that shows this. So let's start by saying the number of heads. That's going to give us one row, and we could get 0 or 1 or 2 or 3. Sorry for my handwriting. And then in the second row, this is probability distribution, we're going to write the probability of getting each of those things. So over here, how many times did we get 0 heads? Well, that only happened once. I'm gonna kind of color code this from here on out. So we got 0 heads one time out of the total of 8. So the probability of that occurring is 1/8. The next option was 1 head. So 1 head occurs here and here and here. So the probability of getting 1 head was 3 out of 8. Then we have the probability of 2 heads that occurred here, here, and here. So the probability of getting 2 heads was 3 out of 8. Sorry if you can't see that, it's in yellow, it says 3 out of 8. And then finally, I'm not going to circle this one, but 3 heads only came up once out of 8 times, so the probability of that is 1 out of 8. You can double check that this works out by adding all these up and making sure that it adds up to 100%. So 1/8 plus 3/8 plus 3/8 plus 1/8 would equal 8/8, and that is 100%. I want to recap one more time. They could have asked for a different thing right here. They asked for the amount of heads, and that told us whatever that first row was going to be, but the second row will always be the probability. All right, we have one more example here. Our second example, example number 4, but our second example with a probability distribution table still starts with a sample space. So it says a closet has shirts of colors red, orange, yellow, and green, along with 3 pairs of socks colored black, red, and orange. And we're going to choose a shirt and pair of socks randomly. Let's start with the sample space before we talk about the probability distribution table. So our sample space, I'm going to use just letters for the colors. So we could choose a red shirt, so R, and then either black, red, or orange. So red, black, red, red, or red, orange. Or we could start with an orange shirt, so we could get orange, black, orange, red, or orange, orange. Or we could start with a yellow shirt, so we could get yellow, black, yellow, red, or yellow, orange. Or we could start with a green shirt, so we could get green, black, green, red, or green, orange. Our sample space is done. I think that's every possible combination of shirts and socks. So there's a total of 12 here. Now let's move on to the probability distribution table. So it says the probability distribution table for if they match or not. So taking fashion aside, I think when it says matching, that means same color. So for this probability distribution table, this is just going to be either yes, they're the same color, or no, they're not the same color. So my first row is going to be if they match. And there's only 2 possible options here. In the last case, when we were talking about the amount of heads, I'm going to go back to that for a second, it could have been 0 or 1 or 2 or 3. This one's a little more simple. It's just they either match, yes or no, only 2 options. So let's start by if they match. We've got a red, red right here. We've got an orange, orange right here. And that looks like it. So out of the 12 options, there's only 2 that match the same color. So for our second row, our probability that they match is 2 out of the 12 options. The probability that they don't match, you could either count them up and there are 10, or if 2 out of 12 match, you can just subtract, and that says 10 out of 12 do not. So this is the probability distribution table. Just to reiterate, they could have asked a different question. They asked if they match, but they could have asked something else. So always make sure you read that.